Now we come to our topic, the interpolation. In interpolation, we shall start with the interpolation of such data which have unequal intervals. Unequal intervals means the height of the data is not same. In that case, the first method is the Lagrange's interpolation. And it is applied for unequal intervals. And for equal intervals, we use the Newton's formula that we will discuss later on. Here we can use Lagrange's interpolation and the divided difference method, but only this method belongs to our concern. Lagrange's interpolation, the main problem is the formation of the formula. It is very complicated formation. If we will try to remember it, it is not possible because data provided is with the 3 values, 4 values or 4 or 5 values. The formula will change according to the given values. Now let us first of all see or learn how to generate the formula for a given data. Then we are able to apply the formula on the given data. Say we are given this x and y. Interpolation, it depends upon the 2 variables x and y. Say in 2000 profit of a company was 100 crore. It means x is 200 and y is 50 crores. There are 2 types of variables. Then if we consider then x1, x2, x3 and so on, here y1, y2, y3 and so on. The values may be 3, 4 or 5. Then f of x, who is x? X is the point of interpolation. X is the point of interpolation that will be provided during the discussions or during the problems. If it is not given, then our data will be converted into a polynomial and we can solve that polynomial for any variable or for any interpolating point. Here f of x is how to generate this formula. We start with the denominator. Say we keep here value x0 and y0. We start with x0. On denominators write down x0, then x0 minus x1. We cannot write x0 minus x0 because that is equal to 0 and we cannot divide by 0 in the mathematics. Then x0 minus x2, x0 minus x3 and so on, depending upon the number of the values. And in the numerator we write the same values with x minus x1, x minus x2, x minus x3. Who is x? It is a point of interpolation. It is a point of interpolation into y0. Into y0. Again I repeat, we started with x0. Do we write x0 minus x1, x0 minus x2, x0 minus x3. Similarly, we can proceed with 4, 5, and in the numerator we keep the same values with the point of interpolation x minus x1, x minus x2 and x minus x3 into y0 plus. Again we start with denominator. Here it was a value x0, we change it with x1. No, we can write x1 minus x0, but we cannot write x1 minus x1, because that will be 0 and we can't divide by 0. So we write x1 minus x2 into x1 minus x3. Similarly, x minus x0, x minus x2, x minus x3 into y1 plus third step, say no, after x1 it comes x2 minus x0, x2 minus x1. We cannot write x2 minus x2, so next term is x2 minus x3, and here x minus x0 into x minus x1 into x minus x3 into y2 plus so on. If the values are more, next we will carry with x3, then with x4. So that is the typical nature of the Lagrange's formula, that this formula changes with the change in the values. So in place of or in spite of remembering it in a fixed format, we must learn how to generate the formula for a given data. It is a Lagrange's method. Sometimes it is asked, solve the data by using inverse Lagrange's method. Inverse Lagrange's method. Then there is no problem. Keep the data in the same manner as it is given. We keep the data same. No. In the result, what we do? We change x with y terms. We change x with y and y with x. If we want to change this formula into the inverse interpolation, Lagrange's interpolation, f inverse x, that is equal to, we can write it y minus y1 into y minus y2 into y minus y3 divided by y0 minus y1, y0 minus y2 and y0 minus y3 into, and here we write x0 and plus so on. We can proceed as we did in the above section. This is the inverse Lagrange's interpolation. So there is no difference in the both methods. Keep the given data in its original or its pristine nature and then change the values of the data in the when we are going to generate the formula. Now let us see an example of this one. Lagrange's interpolation for the unequal intervals. Here x and y, x was the point of interpolation and the inverse Lagrange's interpolation, y was the point of interpolation. Then how we apply it on the problems? Let us see in simple and straightforward example that's by using Lagrange's interpolation. What he says, estimate, we see the problem, estimate the profit for 2006 from the given provided data. Here the data is given, it's the annual session, that is 2004, 2005, 2007, and profit in, we can write in millions, profit in millions of a company, that's equal to 8.5, 12 and 10. Here we have taken the three values, they may be 4 maximum during the exam. It is the data. Now we can see the intervals are not same. 4, after 4, 5, and after 5 it is 7. It means height of the interval is not same. And what is 2006? For 2000, he wants the estimate profit for the given firm. So we can find this estimated profit for 2006, 6 minus 2004 and 2006 minus what is x1? x1 is 2005 divided by x2 2007 minus into 8.5 plus for this 2 into minus 1 divided by 1 into minus 2 into 12 plus this 2 into 1 divided by 3 into 2, that is into 10. That is equal to 8.5 divided by 3 plus 12 and plus 10 by 3. And we can take here LCM 3, the simple arithmetic 3, 8.5 plus 36 plus 10. That is 54.3 divided by 3. So we can find it, that's equal to V. $18.1 million approx. We write it approx because the figures are given round figures. That is the final answer. It means the profit for the 2006 for the given, according to the given data for the firm, was round about 18.1 million. In this way we can find any point of interpolation between the given two points. Now what happens if here we are not provided with x? If the point of interpolation is not given, then we will solve the equation into x, and at the end we will find a polynomial, either it may be quadratic or it may be a cubic. And the advantage of such polynomial is that for any value of x we can solve that polynomial. So that was the Lagrange's interpolation for unequal intervals.